And so that means to get to the nth term, we add 2 n minus 1 times, right? So the nth term is going to be 3 plus 2 times n minus 1. Because we're starting with the first term, 3, and we're adding 2 n minus 1 times.
You know, got an extra pencil?
Yeah.
I got like 5.
Okay, so that's the general idea. Try to figure out what the first term is, figure out what the difference is, and then just interpret what the nth term should be based on that.
Dude, he didn't even do it correctly.
I'll let you guys work on that.
My question, what? 1?
Yes?
I think D is
Yeah. Whoa, so many people absent. Why? What's going on? Liam, does anybody sit next to you? Does anybody sit next to you?
No, I don't think so anymore. Well, Nico did swap
Oh. Were you being annoying, Liam?
No. I think it's strategy.
Wait, no, I have January 6th. January 6th. Did you?
Yes. Yes. Mm-hmm.
Wait, is it always n minus 1?
If you're starting from the first term, then yeah.
Oh, sorry.
What'd you get for A?
Wait, let me.
The 4A average was crazy. I was off by 0.1, but somebody guessed it.
I guess it was.
You're off. Really?
Yep.
That's crazy.
Because people were trying to be strategic, right? They guessed 0.1 less than me and 0.1 greater than me. So that's what. But I was so close, right? Literally so
If you
close.
guess the extra credit, if you guess the average, no one gets extra credit.
Yeah.
So what was your guess for our class?
What did I guess?
So you guess?
I forgot.
You guess like 82.6.
Yeah, something like that.
Yeah, 82.6.
So I was not second closest.
86.7.
Yeah.
To sum off, it's 67.
Yeah. So 4A, 4A's average was 85.6, and I guessed 85.7.
6, 7 actually saved it.
Wow, they were 9. Did you get 9?
Why'd you have such low hopes for our class?
Yeah, that's what I got.
Okay.
Just the
9
trend.
minus 2 and minus
Yeah.
I just don't think he likes it.
It's not personal.
You would remember the
And then just like, oh, those persons like, Lola inside.
Well, you just show work for this. So if you like,
No.
Not making any choice, not making any choice.
Shall we continue?
But once I get to Sigma, do I have to like do Sigma work or?
I will talk about sigma notation. Okay. Let's talk about sigma notation.
This is math. This is serious.
We call this sigma notation because this is the capital sigma. Lowercase sigma actually looks like this, so you'll see that in AP Stats. AP Stats. So let me explain what sigma notation is for those of you guys who forgot. So sigma notation, there is always an index. Maybe we'll call it K. Okay, and then So sigma notation could look something like this. And so k is the index. And 1 is the starting number. And 12 is the ending number. And so the idea is that we're just iterating k from between the starting and ending numbers in increments of 1. And that changes the value of the thing inside. Argument or whatever, I don't know. Okay, so this sum would correspond to, right, the first term would be 5. Right, 2 times 1 plus 3 is the first term. The second term is going to be 2 times 2 plus 3. And then the last term is going to be 2 times 12 plus 3. Okay, so this is going to be 5 plus 7 plus ... plus 27. Okay, and you guys know what this is equal to? 192.
Get it?
You do that in your head?
I did.
You did
Is
it
there
in your
like a
head?
faster way to do
No,
it?
he just knows it.
Yes, I did use the trick, which I will teach you guys shortly. I told you guys about the story about Carl Gauss, right? No?
Oh, no, didn't he?
I did.
Didn't he calculate
Yes.
like one, like 99 factorial or something like that?
No. It's when he was in elementary school, around 6 years old. His teacher, yeah.
It was 1
Good,
plus
that's
2
funny,
plus
Luna, that's
3
good.
plus 4 all the way to 100. That's
Yeah. So his teacher was punishing the class by having everybody solve 1 plus 2 plus 3 all the way to 100. And Gauss was like 5 years old, and he did it in 5 seconds.
Wow.
The answer is 5,050.
Yeah.
And so his teacher was shocked.
Shot?
Shocked.
His teacher was shocked because you did too
No. No.
Wow.
Yeah.
That's like, that's what happens in like, wait, was he in Russia?
He was German. Yeah, I made a very interesting comment about this in 1A, which I will not repeat.
Wait, who in your 1A? Is someone in your 1A?
No. We just had a very interesting conversation because they didn't believe the story. They thought I was lying to them. So I said something. You can ask them. Okay, so summation notation. This is how summation notation works. You just have to know how it works. And let me also show you the trick for how to calculate sums quickly.
What does K do exactly again?
K is the index.
What does that mean exactly again?
It increases from starting to ending in increments of 1. Pretty straightforward. Okay, so how did I do this so quickly? Basically, the trick is the sum of an arithmetic sequence. There is a very simple formula. And it's actually uses the same idea that Carl Gauss did when he was 5 years old. The sum of the arithmetic sequence is the first term plus the last term divided by 2. So the average of the first and last terms times the number of terms. Okay, pretty easy, right? So that's how I did the 192 in my head. Average of 5 and 27 is 16. And so I did 16 times 12, because there are 12 terms, which is 192.
Oh, will this be on the test?
Yeah. Okay, so this formula does need to be memorized, but it's very, it's very straightforward, right? Okay, you guys know how to prove this formula? It's very easy.
By doing it.
It's very easy.
Well, if you say it works, why would we?
No, you need to be skeptical, right? Math, science is a discipline of doubt,
Because
right?
this is just, you prove it by the formula for me.
Okay, let me show you guys how to do it. So let's call the sum S, okay?
Is he on a test?
Just know it, right? It's good for life. suppose you have a sum S and it's an arithmetic sum. So A1, okay, let me use some real numbers just to make this obvious. Let's do the Gauss one, okay? Let's do the Gauss one. 1 plus 2 plus 3 plus 4, all the way to 100, okay? So here's the trick that Gauss used. He wrote a second line in his head, of course, because he was brilliant. He did it in his head, and he wrote the sum down a second time on a second line, but with the numbers reversed. 100 plus 99 plus 98 plus 97, all the way to 1. And then what do you notice? What Gauss noticed in his head in 5 seconds when he was 5 years old was that if you pair them up like this, top to bottom, they give you this, they add to the same number, right? 101 plus 101 plus 101 plus 101 dot 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 plus 101. And so how many terms are there here? There are 100 terms, right? Because that's just the number of terms. And so that tells us that 2s equals 101 times 100. And so s equals 101 times 50, which is 5050. Okay? 5 seconds, 5 years old.
Did he learn that from anywhere else?
No.
But he was never ranked in the state like you were.
Well, he's the greatest mathematician of all time, second to Euler, so I think he's ranked in that way.
Oh yeah, same.
Well, why is he second?
How about
Euler
the guy?
Euler was better.
Is Terrence Tao better than him?
I mean, it's a different era. It's hard to compare.
How about
It's like comparing Jordan and LeBron.
Was Isaac Newton ever made with math?
Huh?
Or was he only with physics?
I mean, considering that Isaac Newton invented calculus, I think he's good at math.
How about Einstein?
Would he be top 10?
Einstein was notoriously not that good at math. I mean, better than, you know,
Even so, he's
A lot of
even better than Einstein at math.
who? Gauss?
Yeah.
I would say so, yeah.
Well, you
But
needed-
isn't Einstein the smartest person?
Einstein is not a mathematician, though. He's a
Then didn't he
physicist.
get E equals MC squared?
But that's a
That's science.
I mean,
That's-
even we can understand E equals MC squared. So.
Here,
What religion was Gauss?
I don't know. Probably not Christian.
what?
Let's see. This
Probably not Christian.
should enable you to do. Oh wait, I need to talk about one more thing. Okay, since you guys might not be aware of this very important statement, so please be quiet. Okay, let me ask you this question. Suppose I had the sum. I don't know why I'm writing in blue. Suppose I have the sum n equals 4. So the starting index is 4 now, and the ending index is 15. And suppose it's something like 3n plus 5, okay? How many terms are there? No,
15.
not 11, and that's what I need you guys to know. There are 12 terms.
Okay.
Do we agree? 12 terms? Do you guys want to count them?
How do you know how many questions?
4,
What about
5.
if it's negative?
Okay, let's count them.
Oh. We're doing, oh.
How many numbers did I just write?
Probably 12.
12.
Wait, good.
Okay, everybody gets tripped up here, and you don't want to be that person, because,
Stop.
okay?
Can you explain?
It's not 15 minus 4. It's not 15. It's 15 minus 4 plus 1. You have to add 1. Why is that? How many numbers are there between 1 and 15?
16. I mean,
15.
There are 15 numbers,
First of all, how do you get 6?
right? 1, 2, 3. This is literally how to count, right? 1, 2, 3, 4, 5. So there are 15 numbers. But that's not 15 minus 1, is it? That's 14. So it's 15 minus 1 plus 1. So you have to do that.
15 minus.
Okay, don't be fooled.
So 15.
You know, this makes us rethink everything. Like, do we even know how to count, right? 1 through 15. There are 15 numbers, right? It's very tricky. But don't forget to add 1.
What do you mean by 15 minus 1 plus 1?
Like when we're counting the numbers between 1 and 15, it's not 15 minus 1, it's 15 minus 1 plus 1. Right? So 15 minus 4 plus 1 gives us 12 numbers for this one. Okay, so for example, the number of numbers between 10 and 20 is not 10, it's actually 11. Okay. So when you calculate sums, just find the first number, the last number, and then average them, and then multiply by the number of numbers. So pretty straightforward. You guys finished with question 3?
Wait, what is the last number? The last number is 13. So it's 14 over 2 times
B is wrong.
13.
Missing a sign.
Huh?
Missing a sign.
The sign?
Mm-hmm. Negative 13 times 15.
Negative.
Yep.
It's like 1, 1, 1, 1, 1. I don't understand.
So 13. No, that is one. That's the starting number.
Yeah. And then you iterate until you get 13.
Well, Mr. Nine, answer the first question 91.
Mm-hmm.
Okay.
Wait, it's 91?
Yeah.
Okay, I'm getting it.
A event equals n, is that right?
Huh?
For number 3, A event equals n, right?
Yes.
And the first term is term 0 or term 1?
Well, it starts at n equals 1, so the first term is 1.
And is B 216?
Find the first term, last term.
Negative 216.
Nope.
Negative 13 times 15.
Use your brain.
136.5. 136.5. What?
How could you get a decimal by adding integers? Right. Just logically speaking.
I did it right, didn't I?
Evidently not. Why are you starting at 7?
4.
I mean, first of all, it's not 7. And also, 7 plus 13 is 10. Divided by 2 is 10, not 10.5.
Oh, wait, the first term. Wait, the first term.
Quite
Hold on.
a lot of mistakes.
Oh, hold on. So it's 7 times 13. So the answer is 81.
Yeah.
Is 3B 195 negative 195? I use the formula. The first term minus, first term plus last term divided by 2 times number of units.
Let's continue.
Wait.
Remember that it starts at
So next term, so first term is gonna be.
Thank you.
And the 15th term is.
Wait, I don't want to do this one.
7.
Let me do
And then
5, 10, 20, 40. Narration is not needed. Narration is not needed.
negative.
Okay, so geometric sequences. Instead of adding for every successive term, now we are multiplying for every new term. And typically we're going to use the letter R to denote that. R stands for ratio. Okay, so the ratio of one term to the term that precedes it is going to be 2 in this case, because every new term I'm going to multiply by 2. All All right, so to find the nth term, it's the same exact idea, right? If we're going from the first term to the fifth term, we're multiplying 2 4 times, right? We're going from 1 to 5, so that multiplies 4 times. So that means the nth term in this sequence is going to be the first term, which is 5, times 2 to the power of n minus 1. Okay, that's because 5 is the starting number. And so to get to the nth term, I'm multiplying n minus 1 times by 2. So it's going to be 2 to the power of n minus 1. That'll give me the nth term. Okay, so r can be any number, except 0, I guess. And it can be a fraction. It could be 1/2, 1/10. Any questions? You guys can probably do number 4 very quickly. That's mine. Any questions? So yeah, let's talk about how we can add geometric sequences in series. Okay, so let's talk about sum of a geometric sequence. Do you guys know what the difference between a sequence and a series is? Okay, sequences are finite and series are infinite. So that's the common language that we would use in math. So a geometric sequence is like 5a and 5b. Those are finite sums. But a geometric series is an infinite sum. So n can go all the way to infinity. Let's talk about sequences for now. Here is the formula for a geometric sequence. So suppose the first term is a, and the ratio is r, so the next term is ar. Third term is ar squared. Kenji, you should listen, it will help you. And the nth term is, anybody? The nth term? Thank you. So there are n terms in total here, right? And the formula for the sum is going to be given by a times 1 minus r to the power of n divided by 1 minus r. To be totally honest with you, I don't actually have that memorized until today. So you have to memorize it, but it's just not very commonly used in real life. So
That's when it's infinite, right?
this is finite.
A times 1.
Okay, so let me explain the structure of this formula. A is always going to be the first term, okay? So that's going to be your first step, is to find the first term of the sequence, and that'll give you A. Okay? Second very important step is to find R, which is the ratio. That's not hard. And then the third number to care about is N, which is the number of terms. Number of terms. So it's pretty similar to the procedure for the previous one, just with a different formula. So for instance, in 5a and 5b, you'll have to convert it to, right? You have to write out the sum and figure out what the first term is, the ratio. And the ratio is always the thing that's being exponentiated, okay? Because that's the thing that we're multiplying by every new term, okay? So for example, if we were to add n equals 1 all the way to 10 of 2 to the power of n minus 1. All right, what would be the first term? Anybody?
1.
First term is 1 because it's 2 to the power of 0. And then the ratio is 2 here because that's the thing that's being exponentiated. All right, so we have 1 plus 2 plus dot dot dot. We actually don't even really need to calculate the 10th term at all because that's not even featured in our formula, right? So I won't even calculate it. And then if we apply this to the formula, the first term is 1, so that's A. And then we have 1 minus 2 to the power of 10. The reason for that is because 2 is the ratio, so that's R. And there are 10 terms, right? We're going from 1 to 10. So that's 10 terms. So it's going to be 1 minus 2 to the power of 10 divided by 1 minus 2, which is, anybody?
-1.
1, 0, 2, 3.
I was right too.
Okay. All right, by now we should have all the powers of 2 memorized up to 10,000, so.
2, 4, 8, 62, 64, 128, 266.
Did we get a calculator on this test in order to?
Nope.
So how far?
Just, if you don't memorize them, you can just multiply it by 2 10 times, right?
Oh.
Well, he's gonna get freaking 64 to the power of
Huh?
96.
Like, what if the number is not 2, it's really big?
I will keep the numbers manageable. From a certain perspective.
To a certain Mr. Nye.
Yeah.
Didn't get the number.
Yeah, that's a Sigma thing to say.
Yeah.
Yeah, I won't be evil.
Mr. Nice is a Sigma today.
I know.
Okay, let's also talk about infinite sequences or series. So let's talk about sum of series. Okay, so on the test it'll be similar to this level of computation, right? So it's not horrible. Okay, sum of geometric series. So these are very similar, except they go to infinity. Okay, so it goes on infinitely long. And please also note that this only works if r is between -1 and 1. Okay? Why does r have to be between -1 and 1? Otherwise, the numbers would tend towards infinity, right? Every term would grow exponentially, and there's no way to sum those. On the other hand, if r is less than 1, then actually the terms will decrease exponentially. And the sum will actually converge to a certain number, which allows us to calculate it. All right, can anybody guess the formula? Using your brains? Anybody?
Same formula, but n.
It's the same formula, but n is infinity, so what's going to be the formula?
Infinity.
No?
Infinity divided by.
I'll just say it. Okay. Okay, formula is a over 1 minus r. Why is that? That's because we're actually applying the same exact formula. We're applying the same exact formula, except now n is infinitely large. But if n is infinitely large, that actually means that r to the power of n will be just 0, right? Because r is a fraction that's less than 1, and so any fraction less than 1, to the power of a super big number is just going to be 0. Right? So it's the same formula, just without the minus r to the power of n. So the steps are the same. You figure out the first term, the ratio between every term, and then you just plug it in.
It actually reaches 0.
I mean, yeah. Like 1/2 to the power of infinity, that's 0. Yeah, approach 0, sure. We'll talk more about that when we get to limits. Okay, let me give you guys an example. So suppose we had 1/2 plus 1/4 plus 1/8 plus 1/16 ad infinitum. What is the answer?
I thought it was ad infinitum.
I don't know Latin, so. What's the answer, guys?
A
1.
over 1/2 over 1/2, so it's 1.
Okay, you should actually be able to see this geometrically. It's actually a very beautiful geometric proof, right? If we draw a square and we divide it in half, and then divide one of them in half, then in half, then in half again, half, 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 half. That comes out to 1 square, right? This is 1/2 of the square. This is 1/4 of the square. This is 1/8 of the square. 1/16.
getting really, really close to 1?
Huh?
Would it be like not getting to 1, but really close to 1?
You do it infinitely amount of times, so it's just 1.
Wait, how do you get to 1 again? I don't.
Like using the formula? The first term is a, so that's half. So the first term is half, and then r is also half. Because the r is the ratio, right? So every new term we're multiplying by half. So it's going to be 1/2 over 1 minus 1/2, which is 1. Okay, but this is a very beautiful geometric proof that you guys should know. Ayla? Huh? No, it's only for half. Yeah, this square logic only works for half, so.
That's the craziest thing I've heard ever.
Okay, I'm done with my lecture.